All right, so if I were to draw this graph, where would time go? On the horizontal. Where would height go? Up here. Now, I would like to think everybody in the class was able to draw that part of it. Excellent. Now, here is where a great many of you are going to make your first mistake. You probably have your first dot right there. That means your swing is sitting on the ground. Awfully hard to swing when your swing is on the ground, because that says 0 time and 0 height. So I'll wait for everybody to fix the first part of their graph. So it has to start a little bit off the ground. What happens to your height immediately when you start swinging? It goes a little bit up, doesn't it? But not very high, because you can only go this far, right? So your swing moves that far. What then happens? Your swing goes down. Does it go ever below this line? No. So your swing goes up and then down. Then what happens? It goes higher and higher each time. Does your speed increase? Yes, it has to get steeper because you are going through that height in less and less time. So the graph must look like this. Now, somebody always draws it this way. Apparently, that person swings so fast, they go back in time. They swing at the speed of light. They get on the swing when they're 5 years old, and they get off the swing and they're 3. Always somebody draws it that way. I am not going to walk around and find the person that drew it that way. I'm going to trust that that person is erasing their graph and fixing it quietly right now. The other thing I like is when the person graphs it this way. The height goes up, the height goes down, the height goes up, the height goes down, and they draw it like this. Because again, the person is going back in time and doing a loop-de-loop, which is, of course, impossible on a swing, unless you have solid bars. If it's on a chain, you cannot swing around. No matter what the kid in grade 6 told you when you were in kindergarten. This one time, I swung so high, I swung all the way around. It cannot happen. They were lying to you. It's always your big cousin. Yes. But if they have a solid bar, it's possible. You can make a porch swing go over if it's on solid bars. Because when you get up to the top, you technically have no speed. Right? Once you have no speed, you go straight down. The chains will not hold you there. That is why when you go to an amusement park that has a ride that turns over, it's solid. Because it has to be. Now, draw a distance time graph. Where does time go? Down here. Where does distance go? Here. I start at 0, I end at 400. That would get you 1 mark. Because that is not how a race goes, is it? No. Because it's distance, Jimmy Brar. How does a race start? How do you start when you start running a race? Some of you have run races before. Do you start like this? No. How do you start? You start slow, or do you have a little bit of an oomph at the beginning to get in front? Little bit. So you cover a lot of distance in a little bit of time, right? Then what do? You settle down to your running pace, correct? And you run for a while, Then what happens right near the end? You sprint again and cover a lot of distance in very little time. That would get you a 4. Now, if you are sketching this right now and not paying attention to my explanations, that's okay, because of course I am recording it. Displacement versus time. How is that different? It's got to come back to the start. So your graph is going to go away and come back. Right? Everybody understand? Now, obviously, could be different steepness and stuff in there. I don't care about that. The point I'm trying to make is in a displacement graph, you come back to home. In a distance graph, you do not. So what level is this point? If it took 1 minute to run the race, how far away am I at 30 seconds? How far? 200 meters away, because I'm halfway through the run. Got it? Excellent. And lastly, wait a minute, Mr. Myers, you've never used the word position. What would position be? Displacement or distance? This is when I decide if you actually paid attention when I explained displacement and distance. That is displacement. Very well done. So, is everybody's graph going to be the same? No. I'll do my graph. This is how my morning went. I woke up, I was in my house. So what was my distance from home? 0. I then drove 8 kilometers to the bus stop that I catch the bus from. So I drove 8 kilometers at 50 kilometers an hour because I was driving in the city, right? So that took about 6 minutes. Everyone agree? All right. So here we are at 6 minutes. I've gone 8K at a pretty constant speed. Then I was sitting in my van listening to music, waiting for the bus to come. And I was listening to music. I was sitting there and I looked up and there was the bus. He was 3 minutes early. So, oh my God, I unlocked the car, jumped out, closed it, locked it, ran over to the bus, and he drove away. So he was 3 minutes early. So I then had to sit here for half an hour. So here I am at 36 minutes, and my distance hasn't changed. Then I got on the bus, which took me on the highway for 20 minutes at a constant speed to get me to Abbotsford, which is, at that point, is 30K from my house. So I was going faster because I was on the highway. So is it going to be a steeper line than this or a less steep line? Steeper, because I'm covering a lot more distance in 20 minutes. Then I walk here from where the bus drops me off, which is over by the Abbotsford Arena that this town built so they could have a hockey team. Oh, wait. They screwed that up. I walk from there to here. That takes 20 minutes to go 2.5K. So it's a very shallow line. 20 minutes to go 2.5K. And that's what my trip here looks like. Okay? Now, what would it look like if right here I realized I forgot my wallet and couldn't pay for my bus fare? I would have to go back home, then back, then wait, and then the rest would be the same. Does everybody understand? Good. It is 1 o'clock. I would like to see you have done some of 155 through 160. All the answer there. Do as much as you see fit. And for the next 20 minutes, I would like to talk about page 163 and 164. And then I'll be done. And the assignment that goes with 163 and 164 is the last few questions on page 158 or something. So if everybody could go to 163, that'd be really good, and we'll talk about this. I want to graph this. To graph this, I need some data. right? Where do I find the data? It's in the question. What's going down here? Read the question, decide on the variables, tell me what they are, and tell me what's going down here. Time is what we're measuring in days. So we need what the variable is, how we're measuring it. And we have data for how long? So I need 7 days here. 1, 2. Try to make it as even as possible, but it's just a sketch, so it doesn't really matter. Everybody good? All right. What's going over here? Cost measured in what? Dollars. Excellent. First day, how much does it cost? $65. So I'm going to go up in fitties. 150, 200, 250, 300, 350, 400. Everybody agree? Everybody good? Okay. So let's start this bad boy. $65, a little past 50, right? So that's where I got to start. Is it an open or a closed dot? You say closed, Jimmy? Why? You don't know. You're just saying an answer. Okay. Open or closed dot? Let me put the question to you a different way. What is the time right there? 0. If you have not rented the car, do you pay yet? So I'll ask again. Open or closed dot? Open. Yay. Open dot. The second you say, I want to rent the car, how much do you pay? $65. For how long? The whole day. Open or closed dot at the end of one day? Closed, because you're renting the car for a day. Right? All right. Let's fill in the rest here, shall we? What happens after a day? I go up to what? 130. Agreed? Open or closed dot? Closed? Well, I'm asking you. That means if you close that dot, that means that one day I'm paying 65 or 130. Which am I paying? 65, because I've only had the car for a day, haven't I? So this must be an open dot. Till when? Till the end of the second day. What happens on the third day? Goes up again to what? 195 for that whole third day. What changes then? I only go up by 30, so I'm at 195, so my next one is what? $225. All the way out to 4. What's the next one? $255. All the way out to 5. What's the next one? $285. All the way out to 6. And the last one? $315. All the way out to 7. Now, there's all my points on the graph, right? The question that I'm asking you is, should I connect them? What are the ways I could connect them? I could draw this line, couldn't I? That would connect the points if I didn't get lame at the end. That's one way I could connect, yes? These are also points on the graph. I could connect them too, couldn't I? And the other place I could connect points would be right here. Do any of them make sense? Should I have the blue line? Does that make sense? No? Okay. Should I have the black line? Does that make sense? Why not? What about the black line bothers you? It's going through open dots. Do any of those dots exist? No, so it can't be the black line. What about the green lines? What's wrong with them? Aren't they going straight up and down? Aren't they going straight up and down? Well, wouldn't that mean time had stopped? Can time stop? So we can't use the green ones. So I'm going to come back to that original blue one. Is that okay? Charlotte is assuming it is. It's going through dots that exist. It's making a line, because we like graphs with lines. Yeah? So, here's what. I'm going to put that line in there, correct? Everyone agree? And it goes all the way along, yeah? Tell me how much I need to pay if I want to rent the car for 1.5 days. How much do I pay? Don't look at the graph, look at the data. How much do I have to pay if I want the car for 1.5 days? I pay $65 per day. So how much do I pay for the first day? $65. How much do I pay when I hop to the second day? Another $65. So how much am I paying? How much am I paying? $130. Because I pay for the day. If I draw that line, that means I'm getting some kind of deal at 1.5. I'd be paying something in between 65 and 130. Am I? No, I pay for the day. Everybody understand? So I cannot connect any of these points. Why? Because there's no allowable inputs between days. I am only counting whole days. Does everybody understand? Is everybody good? All right. Now, the next question, though, is it a function? Vertical line test goes right through 2 points. Is it okay? Why? Because that's an open dot, so it doesn't really exist. Yes, because the dots are open. Now, finally, domain and range is very tricky. I'm going to let you have a look at it and give it some thought. Domain, I'll write in red. And range, I'll write in blue. Talk to your neighbor about it for a second. Look at the graph. See if you can figure it out. All right. Where does domain live on a graph? Most of the time. X-axis. So, is there a value for x all the way to 1? Is there an output all the way to 1? Yeah, because I pay $65 for the whole day, no matter how much time, right? What happens right here? Is there an output still? So the line continues on. Does it go all the way to 7? Yes. So my domain, what's the lowest amount of time I can rent the vehicle for? Can I actually rent the vehicle for 0? So it's 0 less than what? Time or days. I don't care which one. Up to a maximum of what? 7. Can I keep it for 7 days? So do I need an equal sign here? Yes. Is everybody good? Okay. What then is the range? Is it possible that I pay nothing to rent the car? No, because I haven't rented it yet, right? So, I can't have 0 as a range. What's the next one I can have? 65. Can I have anything between 65 and 130? No. So I cannot do this. I must list. Does everybody understand the difference? This is the first time you've seen one of these where the domain is solid, but my range is options. Does everybody get it? Okay. This is what is called discrete and continuous data. Discrete data means there is not available outputs for every available input. Okay? Everybody understand? Let me give you another example. This will be separate. I am here first in the morning, right? I'm here before all of you, yeah? So as time goes on, this room fills up with people, doesn't it? How does it fill up? One person at a time. Can half a person walk into the door? No. So there is no available input or output for fractions in that example. Do you all understand? Right? Everybody gets it? Like there's no such thing as half a person. I get in a car wreck and I lose my legs. I'm still a person. Right? I get in a car wreck and I lose my left arm and my left leg. Don't worry, I'm all right now. Lose my left arm, my left leg. I'm all right now. I know. It's still funny. Yeah, it is, because you're laughing right now, so I know it's funny. Right? I do a lot of stuff over and over, and you guys still laugh at it. Doesn't make it any less funny. All right. Everybody good with discrete? So then what's continuous? Available inputs and outputs for all values. Everybody understand? Okay. I'll let that sit for a moment. We've got 4 examples to do, and then we're done for the day. Step 1. Number 1, I want the dV, the IV, and if it's discrete or continuous, with the reason. Talk to your neighbor if you need to. I want all 3 of those for all 4 of these examples. All right. If you're unsure, let's do the first one together, and then you can carry on. Speed of sound in air is related to the air temperature. Which is the dV, which is the IV? Jeshen? Pardon me? dV is air temperature. That's your guess? Okay. I know this is going to be an impossible thing for all of you to do, but try it. Nobody make a sound. See? Couldn't even last that long. I already heard the sound. Nobody make a sound. Still can't do it. I know it's Sevik. He thinks it's funny. Nobody make a sound. Let's pretend you can all follow the simplest instruction I could give you, which is sit there and do nothing. Some of you failed at that. Is there still an air temperature? Yeah. Everybody understand? So air temperature is the IV. Speed of sound is the dV. Now, is it discrete or continuous? Is there always a temperature? Down to every single tiniest decimal place. Is there a temperature? Yes. When sound is passing through that temperature, does it always have a speed? Or does it go at certain speed, then disappear, and then start again? It's constant, isn't it? So this is continuous. Because air temp and speed are constantly there. There is no stopping them. Right? When it gets cold in the wintertime, it doesn't go from 5 degrees and then the world disappears and then reappears and it's 0 degrees, does it? It goes from 5 down to 0 through every decimal place on the way. Everybody get it? Great. So that should help you do 2. What's the dV? What's the IV? IV is age. Why? You could look at it that way. You could read the question and understand the syntax, or you could understand what's actually going on. Do I have an age right now? Do you have an age right now? Am I a female? You don't technically know, but am I? So since I have an age and you have an age, that's the IV. The dV is the dose. Now this is tricky. Is it discrete or continuous? It's discrete. Why? Because it's based on years. So if I'm 37 and a half, I do not change my dosage, because it's based on my age in full years. Everybody understand? And if you go home and you read the side of a medicine bottle, it'll say, if you're under 12, take 1 pill. Doesn't matter if you're 6 or 8, you're taking 1 pill. If you're over 12, you take 2 pills. Of course, nobody does. Whenever I have a headache, I take at least 4. But that's just me. Number 3, juice and cost. What's the independent variable? E-juice. What's the independent variable? Cost? So if cost is the independent variable, that means when I go into the store, if I don't buy any juice, they're going to take my money. Is that how 7-Eleven works? I feel like a bottle of orange juice. Walk into 7-Eleven, give me $2.95. Or do you have to buy the juice first? Right. So the DV is cost because how much you pay depends on the cans of juice. Discrete or continuous? Discrete. Why? You can't buy half a can of juice. You can try. Glug, 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 glug. I'm not thirsty anymore. Here, give me back $1. They won't do it. Not even Costco will do that. And Costco will let you return everything, even swimsuits. Yeah. And finally, altitude is related to air temperature. What's the DV? What's the IV? This is a tricky one. Temperature is DV because as you go up, what happens to the temperature? It gets colder. Discrete or continuous? Continuous. Why? It changes constantly. As I walk up a mountain, I don't teleport from one spot to another. I have to pass through all those altitudes, and at all those altitudes, there's a temperature. Every altitude has a temp.